Okay, so in this session, I am going over 3.1, which is the rectangular coordinate system. I'm actually going over some things that aren't directly covered in 3.1 and aren't really they're sort of covered in 3.2, but I'm going to be looking at it in a different way, I guess. So I've put it in with 3.1 because I'm going to be looking at it more as looking at the ordered pairs versus looking specifically at lines, which is what 3.2 is about. So it's a little mix of 3.1, 3.2, but the goal is going to be graphing and then finding ordered pairs. So starting off with how to read graphs and tables. So when you are given a table of values, the first column, because they're usually going up, they're usually vertical. Sometimes there's horizontal tables, but usually they're vertical, so they're going up and down. The first column is always your input value. The second column is always your output value. Now, when you read a graph, you have a vertical and a horizontal component. And for a graph, the horizontal part is always going to be your input, and then the vertical part is always going to be your output. So those are the keys to how you read graphs and tables so that you know which part is the input, which part is the output. What we graph with is called the rectangular coordinate system. It's also called the Cartesian coordinate system after René Descartes, who was a French mathematician and philosopher in like the 1600s. So the rectangular coordinate system, what it looks like usually is that it basically has a plus sign. And so you've got a horizontal portion and a vertical portion. Sometimes you'll only look at one section of the graph and you might have basically an L part. If you only look at the top right, you might have a graph that looks like that. So that is called quadrant 1. It's divided into 4 sections, and quad means 4, so that's why they're called quadrants. And we actually name them counterclockwise. So the top right is called quadrant 1, and we call it quadrant 1 because that's the most common one used. And then to the left is quadrant 2, and we go down, that gives us quadrant 3, and then to the right is quadrant 4. So we've got these horizontal and vertical lines. So these are called axes. So this is the horizontal axis, or it's also called the x-axis because we use that to represent x. And then we have the vertical axis, which is also called the y-axis. So we use that to represent y. These are basically number lines. So we're basically taking 2 number lines and we're putting them together to make a plus sign. And so if you're looking at the horizontal axis, and if you look at it as a number line and you ignore the vertical, then this middle is called the origin. That's where 0 is. So the part where the 2 number lines cross is 0. And so on the number line, everything to the right of 0 is positive. Everything to the left of 0 is negative. So I can count these, and each tick mark will be counting by 1 unless it's specified. Sometimes we count by 2s or 3s or other things. So the positive numbers are to the right, and the negative numbers are to the left. And so you count to the left negative, just like a regular number line. When we look at it vertically, where we have the up and down, you want to think about it in terms of maybe elevation. When you're climbing a mountain, when you go up, we consider that positive elevations. You know, say a mountain is like 20,000 feet above sea level. That's a positive number. And things below sea level, we usually use negative numbers. So when you have the vertical, you have your positive numbers going up. And so I'm going to write these in a different color. So that's 1, 2, 3, and it counts going up. And then the negatives are going down. And so you still have a number line, but on the vertical portion, it's positive going up, negative going down. And so then this corresponds, we have these parentheses underneath the labels of each quadrant. So these are called ordered pairs. So an ordered pair is we have a pair of numbers and we just refer to them with parentheses, and then we have two numbers. And so in quadrant 1, both of the values are positive because you're in the positive part of the x and you're in the positive part of the y, positive part of both the horizontal and the vertical. On the left side, it's negative positive. That negative comes from the horizontal axis. So our first part is always an x. So we always reference things in terms of horizontal first and then vertical. And so the y value, the vertical value in that quadrant is positive. So that's why you see a negative and a positive in quadrant 2. So if you're trying to remember how we write these, think of it as alphabetical order. X comes before Y, horizontal comes before vertical in the alphabet. So we always put these in alphabetical order, and that's how you can determine where your numbers should go, and then you can also determine what the signs are of the numbers. Are there any questions on what I've just explained with graph and like kind of the vocabulary and what these things mean?
No.
Okay. So looking at it, here's a picture where we've got some actual ordered pairs here. So any point, if you have a single dot, we call that a point, and it's also called the value of that is called an ordered pair. And so as I mentioned on the previous slide, these are x comma y, so your horizontal value and then your vertical value. And so on this graph, you can see where the name rectangular coordinate system comes from, because you can see that when you draw lines to get to your point in terms of the axis, you're forming rectangles. So that's how we get the name rectangular coordinate system. So if we look at the green point, its value is considered 2, 3. So that 2 is always your horizontal point, and then 3 is the vertical. And so you're looking at, if you had drawn a line, so where does it hit on the axis, and then that's your number. So 2, 3, that point is above 2 on the x, and it's to the right of 3. And so if you're drawing lines horizontally and vertically, those are the points that it connects to. When you're graphing, you usually have to estimate when you have things with decimals. So it's a little harder to graph things with decimals. So the blue one does have decimals. It's -1.5 and -2.5. And you have to sort of estimate that because it's not falling on a whole number. So one of the downsides of graphing is that sometimes it's hard to read a graph when you have decimals if they're not whole numbers. So that's just just an FYI. Most of the time we're going to stick with whole numbers whenever possible, because those are a lot easier to work with. So I have an example here, and I'm going to just go through and show how each of these are plotted. So how you have an ordered pair, and then where you would put that when you have to graph it. So the first one here is 4, -2. So it's always your horizontal first and then the vertical. So I always start, you start at your center point. So 4 means I need to go 4 to on my horizontal. So I'm going where 4 is here on the horizontal. And then 2 is the vertical. So now I need to find where 2 is on the vertical. And so when I form that rectangle, where those sort of intersect, that is my point. 4, 2. So you can think of it as you're going to the right 4, and then you're going up 2. And that gives you your ordered pair. Now normally we don't draw the rectangle, so all you would see would be that point. You kind of do that in your head, you think of that rectangle so that you can figure out where that point is located. The next one is -4, 2. So that negative means that we're now going to the left instead of the right, because the first value is always your horizontal movement. So I'm going to the left to -4, and then 2 means I need to go up so that I'm across the 2 on the vertical. So that is -4, 2. Now you want to be careful because sometimes you can see that, okay, I've got dots and I can just count, okay, I went up 2 dots. But not every graph counts by ones. Sometimes they count by twos, and so a dot might represent 2 instead of 1. So you always have to look to see what your graph is counting by. And you figure that out by looking at your first tick marks. And that tells you. So if your first tick mark, that's what these little vertical lines are, these little hash marks on the axis. If your first one is labeled 1, that means every single mark is considered 1. So you're counting up by ones. If the first one was labeled 2, that meant you're counting by 2s. So you go 2, 4, 6, 8, and so on. So you always want to pay attention to those so that you know what you're counting by, because you're not always counting by ones. The next point I have here is -3, 0. And Jeanette, when you have to make a graph, can you make your own? Yes, when you make a graph, if you're not given a graph, you can count by whatever you want. And if you do that, it's always important to label it so that somebody else knows what you're counting by. So that's the importance of making sure everything's labeled so everyone else knows. But you can count by whatever. If you want to count by 2s or you want to count by 5s, you can do whatever you want. Most people choose to count by 1s, but if you have really big numbers, like you're graphing things in the hundreds, you may want to count by something bigger because you don't want to draw 100 tick marks. So the next point here is -3, 0. So the negative is at first value, means I'm going to the left to -3. 0 means I don't move anywhere. So my point is just purely horizontal. We say that that value is only on the horizontal axis. It's not in a quadrant. So a point is in a quadrant if it's kind of floating away from the plus sign. It's on an axis if it's actually on one of the number lines here. The next one is 0, -3. So you always start from the center. 0 means you're not moving left or right if 0 is your first value. So you're not moving left or right. Your second value says -3. So that means you're going down to -3. This is also on an axis, but this is on the vertical axis or the y-axis instead of the x-axis. Then I have -4, -2. So I start with the center, and I go to the left to -4, and then I need to go down until I'm at -2. And then when you see 0, 0, that is the center point. So 0, 0 means you're not moving anywhere, so you're just stuck at that center. Are there any questions on how to plot points? I'm going to bring up Desmos just to kind of show you how you can do this on Desmos if you don't want to do it by hand. So the nice thing about Desmos is all you have to do is plot, is you just have to type them in exactly as you see them. So you have 4, 2, and then it will plot it. And you hit enter, and then you can just do the next one, -4, 2. And so if you're plotting with Desmos, it's nice because they just automatically show up. So I'm just going to type all of these in. Oops. And then it just puts a dot at every single one of these. And then it also has them color-coded. Looking at Desmos, our first label is at 1. So each of these gray lines we're counting by ones. But you can change that. If you go to this little wrench, you can go to the settings. And step tells you what you're counting by. So I can count by twos. So if I type in 2, now the gray marks, those are every 2. So now it's counting by twos. And so you can see that you can change, you can count differently. You don't have to count the same going up and down as you do left and right. So you can still count by ones going up, but you can count by twos going left and right if you want. So you basically can control what you want to count by when you're making the graphs. When you zoom in with Desmos, it won't affect those settings that you made. If you change the settings and you say to count by twos, it's going to count by twos. If you want to undo that, you just clear that, and then it will go back to counting. And you can zoom in, and if you zoom in enough, then it switches and it starts counting by smaller increments. So it changed, so now it's counting by 0.5 instead of 1. And if you zoom out enough, it starts counting by twos, or then fives. And so it all depends on how you want to count. Desmos can change that based off of your view and what you want to look at. So that is basically all that 3.1 goes through, but I also want to go over how you plot equations in this, in addition to just reading graphs and plotting ordered pairs. A lot of times you have to graph an equation, and how do you do that? So in order to graph an equation, you have to get ordered pairs first. So you have to figure out what those pairs are. They're not given to you. And so the best way to do that is by you basically make a table of values. Because they're not given to you, you get to make them. You get to pick them yourself. So generally, you pick the input values, the x points that you want to use. A good way to plot is always to have some negatives, to include 0, and to have positives. That will make sure you have a good picture of the graph. If you have only positives, you may miss some parts. So you want to have some x values that are negative, an x value that's 0, and an x value that's positive. So you can pick any numbers you want. If you want to do -5, 0, and 10, you can do that. Once you have x values, and you can choose whatever you want, then you put them in your equation. So you're replacing x in your equation with the actual number you picked. And then that will give you an equation with only one variable. And so then you solve for y, and that will give you the missing part. And once you figure out what y is, you now have an x value and a y value, and that's an ordered pair. And so then you plot it, and then you connect all of your points, and that will get you your graph. So I'm going to demonstrate this in example 2 here. So I have an equation, and it says graph this. Well, how do we do that by hand? We want to make a table. So I'm going to just fill in a table here. Your input is always x. Your output is always y. And we can pick any x we want. But I recommend we do a negative, we do 0, and then we have a positive number. I personally like to do -1, 0, and 1. I choose -1 and I choose 1 because those are easy. If you have to do any multiplication, it's really easy to multiply by -1. It's really easy to multiply by +1. And then we want to have 0. So those are the numbers I like to choose, but you can choose any number you want. If you have something with fractions, I usually choose a number that I can divide by the denominator. So if I have a fraction and it's 1/3, I will pick numbers like 3, 6, or 9, things that I can divide by that fraction, because that usually makes things easier. But you can pick these x values. You can choose anything you want. So I just pick -1, 0, and 1. If you have a favorite number, you can go ahead and pick it. I do recommend that whatever x values you pick are ones that are on your graph. So if you're given a graph like we have here, you don't want to pick like 10 because that's not on the picture. That's the only thing. And definitely it's hard to pick fractions and decimals, so I don't recommend doing that. So how this works is we take each row. So it's my first row here, I have an x, and in the column for x, I'm -1. So that means x is equal to -1. So in my equation, I have x plus y equals 3. So I'm going to replace x with -1 because we decided we want x to be -1. And so I replace that in my equation. So whatever, any of these values are all going to be replacing x in our equation. Now I have an equation I can solve for y. So to solve for y, I'm going to add 1 to both sides. And that gives me y equals 4. Once I know what y is, that gives me a value I can fill into my table. So x with -1 gives me a y value of 4. And then I graph that. So I'm going to start at the middle. I go to -1 on the x, and then I go to 4 on the y. So that gives me my first pair. Then I do this again with 0. So my second one here, I have 0 for x. So x is equal to 0. So I'm going to put that into my equation. Instead of x, I have 0. So I have 0 plus y equals 3, which just gives me y equals 3. So I start at my origin in the middle. A 0 is on the x, so I'm not moving left and right. And then I'm going up 3. And then I do this with the next point. So my x is 1. So I replace 1 in my equation, and I get 1 plus y equals 3. And then we solve for y. So I'm going to subtract 1 from both sides, get y is equal to 2. So that gives me 1 for the x, 2 for the y, and I plot that point. And then once you've done that, you connect them, and that will be your graph. So this is going to give us a line. It's not a perfect picture, but you will connect those, and you will see that you will get a line. Everything you're going to be graphing this week is just lines, so you're not going to have to worry about anything that has curves. When you get to next week, there will be things with curves, but for now, everything we're doing is a line, so you don't have to worry about trying to figure out, oh, what if it goes back up? These are all just going to be a line. So you just connect them, you have your line, and now you have graphed that equation. The last y is turned to negative. Yes. So if you then were looking, okay, wait a minute. Last x. Anjanette, can you clarify your question?
Yes, you know the last one is.
The
I
one
mean, the last one we did, it turned
yep.
into. Okay.
Yes.
Can you tell
Yeah,
me
because
why
we
is
do
that?
the, oh, sorry, go ahead.
No, I just could you explain why I would turn
Yeah.
that into a negative?
Yes. So we had a positive 1, we had 1 plus y. And so to get rid of a positive, you want a negative. So that's why I wrote -1 there. So that's to cancel out. So that 1 minus 1 is 0. So then because I have a minus on the left, I have to also do it on the right. So that's how I have 3 minus
Okay.
1, which gets me 2.
Okay. Thank you.
You're welcome. Are there other questions? Okay. Now, sometimes they give you the table, and then you have to fill it in. So here we are given a table and we want to graph y equals 5x plus 1. It's a very similar process. So for the first row, under the x we have 1. So x is equal to 1. So I need to replace x in my equation with the x that I'm given here. So I have y equals 5x, and that's assumed multiplication. So that's going to be 5 times 1 plus 1. And so now we want to simplify. We're solving for y. We already have y on its own on the left, so we just need to do the math on the right. 5 times 1 is 5. So I get y equals 5 plus 1, which gives me y equals 6. So then I'm going to start at the middle. I go to 1 on the x, and then I go up to 6 on the y. The next one here, they're actually giving us a y value instead, and that's okay. Sometimes they can give you a y, and you're finding the x. So if you prefer to do that, you can do that. So here, y is equal to 1 because it's under the column for y. So if I was to highlight, let's use green. So in this case, I'm replacing y with 1 because now it's in the column for y. So I have 1 equals 5x plus 1. And so now I need to solve for x because now that's the unknown. So I need to get rid of the plus 1 on the right. I do that by subtracting. And I get 1 minus 1, I get 0 equals 5x. I'm kind of running out of room here, so I'm going to rewrite it. I need to divide by 5 because I just want to get x. So I'm going to divide everything by 5. And 0 divided by 5 is still 0. So I get x is equal to 0. So when I graph this, I start at the center. I don't move left or right, and I just move up to 1. Now this last one, they give us an x value of -1. So I actually want you guys to try to figure out this one. So now we have x is -1. So I'm going to replace it with y equals 5 times our x, which is -1 plus 1. When you simplify that, what do you get? You just follow the order of operations on the right side. It's okay to be brave. You can type it if you want. If you don't want to put it, -4. That is correct. So 5 times -1 is -5. So we have -5 plus 1. We get -4. Thank you. I like to have you guys interact a little bit. So when I graph this, I start in the middle. I go to the left to -1, and then I have to go down to -4. Then I'm going to connect these with a line, and I'm going to do my best to do a straight line. It's not perfect, but now I have graphed this equation. And so now that's what this looks like. And you can graph these on Desmos. So if I pull Desmos back up, I'm going to just delete all of these points. Desmos can graph the line directly, y equals 5x plus 1, And then, see, I can zoom out. And then you can see that it graphs it. That other one that we did, the x plus y equals 3, you can just type that in, and it graphs that one. So Desmos will graph these, but it doesn't tell you values unless you click, and then you can kind of drag, and then you can see certain values. But Desmos will also graph these without doing ordered pairs. Yes, the division part. The part where we divided by 5. We are dividing by 5 because I just want x. I want this x to be by itself. And my problem is I have a 5 in front of there, and that's a 5 times x. So if there's no symbol, if there's no plus or minus, we assume that it's multiplication. So if I have 5 times x, then I need to undo the multiplication, and we do that by division. So I'm dividing by 5 so that I can undo that 5. So then in the next line, 5 divided by 5 is 1. And if I have a 1 in front of a letter, I generally don't write that 1. And then 0 divided by 5 is 0. So that's how I get 0 on the left. Does that help? Are there other questions? Okay, now this last one, this is worded the same way as your assignment. So complete the ordered pairs given the equation 2x minus 3y equals 6. Find y so that 2 comma y is a solution. What we're doing here is we are given one value. We're trying to find what the y value is. So every ordered pair is x comma y. So when they give us 2 comma y, they're telling us x is equal to 2 because 2 is in the spot for x. So x is equal to 2, and it says find y. So I need to find the missing value there. So everywhere I see x in my equation, I need to replace it with 2. So I have 2x, and that's assumed multiplication, and x is 2. So that's going to be 2 times 2 minus 3y equals 6. Now I'm going to solve for y so that I know what y is. So first, on the left side, I need to multiply 2 times 2. So that gives me 4 minus 3y equals 6. So I want to get the y by itself, and right now I have a negative 3y. Those are all connected. I want to get rid of the 4 on the left side with the y. So that's a positive 4, so I need to subtract 4 to get rid of it. I'm going to just move this over. 4 minus 4 is 0. So then I'm left with a minus 3y, and 6 minus 4 is 2. Now I want y. I don't want a negative 3 in front of there. That's multiplied. So I need to divide everything by negative 3. So negative 3 divided by negative 3 is a positive 1. So I don't need a 1 in front of my y. I can leave it as y. And then I get a fraction, negative 2/3. And it's totally fine to have a fraction here. Now we have found what y is, and now we know that our ordered pair is 2, negative 2/3. Camilla, do you have a question? Yes. You can still put a 1 in front of the y if it helps you. There is nothing wrong with putting that 1 there. And if it does help you, I encourage you to do it, because whatever will help you, that's the important part. Other questions on any of the steps that I just did? Okay, now the next one here is find x so that x comma negative 4 is a solution. How do you graph negative 2/3? Okay, so for here, you wouldn't graph y equals negative 2/3. What you would graph is this, if you were to graph what it is a solution. So you would graph the ordered pair. And if you were to do that, you would have to estimate what it is as a decimal. So if you were to do it by hand, you would have to figure out what negative 2/3 is as a decimal and then sort of estimate it. And that would be like negative 0.6 repeating. For something like that, I actually recommend we just use Desmos. So I'm going to just clear these out. The equation they gave us was 2x minus 3y equals 6. So we just found an ordered pair, 2, negative 2/3. So you can graph fractions using Desmos, so you don't have to worry about trying to do it by hand. And you can see that that point that it created is on our line. That's what it means to be a solution. It's a solution if it's on the line. And this is how you can check your work. If we had done our math wrong and had -1, instead the point is off the line. And that would tell you you messed up because that is supposed to be on your line. So if it's not on the line, that tells you you made a mistake. But we found negative 2/3. And so then we can get it. Yeah, and I recommend using Desmos. I don't recommend trying to graph these by hand. It's a great way to do it to make sure you understand what's going on, but most things that you need to do, you can graph electronically. It does make it a lot easier. Especially you can use this for the discussion. You can use Desmos because as long as you what's more important is understanding how to get the numbers and how to read the graph rather than creating the graph. Especially when you have fractions. Trying to graph that would be really difficult. So going back, the next one here is find x. So that x comma -4 is a solution. So now they're giving us y because they're giving us the second value. The second value is always a y. So now I need to replace y in our equation. So we have, let me switch colors. Y is equal to -4. So in this case, we have the same equation, 2x minus 3y equals 6. Be very careful because on the assignment, you have two different equations. So they give you a different equation in the second problem. So my equation here are 2x minus 3, and then instead of y, I'm going to be multiplying by -4. So I have 2x minus 3 times -4. So I need to multiply. That's -3. You can think of that as a -3. So a negative times a negative is a positive. So I'm going to get 2x plus, and then 3 times 4 is 12. So I'm going to get plus 12. Now I'm solving for x. So I need to get 2x by itself, which means getting rid of the plus 12. So I subtract. So I'm going to subtract 12 from both sides. And then 6 minus 12 is -6. So that gives me 2x equals -6 because 12 minus 12 is 0. Now, I need to get rid of the 2, so I do that by division. I divide both sides by 2. -6 divided by 2 is -3. So we found x so that this is a solution, -3. And then if I plug that back in, I have -3, comma, -4 as my ordered pair. And then you would verify that on the graph by graphing -3, -4 to make sure you did it correctly. So I'm going to bring Desmos back up. -3, -4. And good, we did it correctly because you can see that the point is on the line. And so that verifies you did your math right. Are there any questions? When you're writing up your assignment, what you want to show is what I have on this screen. So on the assignment, you don't have to show the graph unless you just want to say that you checked your answer. And if you are going to show checking your answer, then yes, you can take a screenshot of your graph. But what is required for the assignment is what I have written on this screen. So you're not required to do the graph, but it is good if you want to check that your work is right. Are there any other questions? All right, so I just want to show you guys, let me actually go to our class. After this video, for kind of some details on how to do the discussion, so if we go to live sessions and instructor videos, live session recordings, scroll down to week 7. I would watch this linear equations in 2 variables 1. There is some repetition. I do go over some of the same things as I just did here, which actually might be helpful to see it again a second time. But then, and I go over some of the graphing part a little bit again, but then I go into slope and finding slope of a line. That's required for the discussion this week. And then I go over the equation of a line. That is also required for the discussion this week. So to get ready for the discussion, now that you've seen this video, the linear equations in 2 variables is the next step that I recommend you watch. So that's all I had. That was basically everything that I wanted to make sure you guys saw. That next video should cover pretty much everything else. So yeah, that's it. Hopefully, let me just take a look at our schedule because I know, where's my calendar? I can never find my calendar. I probably accidentally closed it and that's why I can't find it. So, oops, I just went ahead a month. And, the week 8 introduction, I'm going to do 2 p.m. For Wednesday. That's going to be the Wednesday before Thanksgiving. Thanksgiving is going to throw some things off next week. I'm definitely gonna make an announcement about that to make sure everybody understands, because the grading is gonna be different, and then it's gonna be interesting. Just as an FYI, and of course Thanksgiving is happening at the last week of class, so that's gonna make it harder for you to find time because you've got family and all that stuff going on. But I just kind of wanted to warn you about that. So if you guys do have questions on anything this week, of course, let me know. If you want me to look over your discussion before you post it, you can just send it to me in email or send me a screenshot through Remind, and then I can take a look at it. So do you guys have any other questions on anything? All right. Sounds great. So unfortunately, only 2 of you ended up in the end. We had like 4 people that started. People probably had to go do things or whatever with work. But thank you guys for joining. I really appreciate it. I'm going to get this out within the next hour so that way you can review it again if you want. You can probably, reviewing it while you're doing the assignment would probably be very helpful, especially this last example. So hopefully You guys have a great weekend and enjoy your weekend, and I will talk to you guys later.
See ya. Thanks.
Bye. You're welcome.